Hey everyone, welcome back. Are you ready for another deep dive?
Always ready to dig in.
Awesome. Because today we're going way, way back, like back to when Earth was still kind of getting its act together.
Oh, sounds intriguing. I'm guessing we're talking about some pretty ancient history then.
You got it. We're talking billions of years ago.
Hmm.
And get this, scientists just uncovered something really cool, the oldest meteorite crater they've ever found.
No way. Okay, now I'm really interested. How old are we talking here?
Hold on to your hats because this crater is estimated to be a whopping 3.5 billion years old.
Wow. That absolutely crushes the previous record, didn't it? What was it, like 2.2 billion years?
Exactly, almost a billion years older. It's crazy, right? This discovery comes from researchers at Curtin University, and they were exploring this area in Western Australia called the Pilbara Craton.
The Pilbara Craton. Ah, yes. I know a bit about that. It's like this huge, ancient chunk of Earth's crust. Basically, a window into the planet's early days.
Yeah, it's like a giant, ancient jigsaw puzzle piece that's been sitting there almost untouched for billions of years.
One of the oldest and most stable parts of the Earth's surface, which makes it a prime spot for finding clues about our planet's earliest days.
Exactly. And what they found there is pretty remarkable. They discovered these unique rock formations called shatter cones.
Shatter cones. Oh, those are cool. They're like these cone-shaped rocks with these lines that radiate outwards.
Right. And they only form under extreme pressure, like the kind of pressure you would get from, well, a massive meteorite impact.
Yeah, that's what makes shatter cones so fascinating. They're basically a geologist's smoking gun, pretty much irrefutable evidence of a meteorite strike.
So we're talking about a pretty big deal here. Now, this crater isn't some gaping hole in the ground or anything.
Right, over billions of years, it's been worn down and reshaped by erosion and geological processes.
Yeah, I can only imagine. But try to picture this. A chunk of rock, maybe even bigger than Mount Everest.
Wow, okay, I'm picturing it.
And this huge rock is hurtling toward Earth at over 36,000 kilometers per hour.
That's insanely fast.
I know. The impact must have been absolutely mind-blowing, and scientists believe the crater that resulted from that impact was probably over 100 kilometers wide.
100 kilometers, that's huge.
Yeah, it would have scattered debris far and wide, and the shock waves would have been felt all over the planet.
It really gives you a sense of just how chaotic the early solar system was.
Right. Remember, the moon is covered in craters from that period.
Exactly. And this discovery helps fill in some of the missing pieces in Earth's own impact history. It's something we haven't been able to study very well because most of the evidence is long gone.
So, this is filling a major gap in our understanding, which is super exciting. But here's where it gets really fascinating, for me at least. The article mentions that these impacts, as destructive as they were, could have actually been helpful for the development of early life.
Oh, that's interesting. How so?
Well, it talks about how the impact could have created environments like hot water pools, which some scientists think might have been where the first microbial life emerged.
Ah, I see. That makes sense. We're talking about the kind of extreme environments that certain types of organisms, like extremophiles, thrive in.
Exactly. So imagine the energy released by such a massive impact. It would have melted rock, potentially creating hydrothermal vents, and maybe even released chemicals that early life forms could have used.
Yeah, it's kind of a wild thought, these destructive events that could have been the spark for life as we know it.
And there's even more. The article also suggests that this ancient impact might have played a role in shaping Earth's early crust.
Wow. Could one event really have that much of an impact, so to speak?
Well, that's what they're suggesting. Think about the energy involved. It could have been powerful enough to kickstart plate tectonics. You know, those processes that make continents drift.
Oh, right, like subduction, where one piece of the Earth's crust gets pushed under another.
Exactly. This impact could have triggered that process, or maybe even forced magma from the Earth's mantle to the surface, contributing to the formation of those stable cratons like the Pilbara. So we got this massive impact that potentially jump-started life, shaped our planet's crust, and, well, the implications are pretty mind-blowing.
No kidding. This is incredible stuff. It really makes you think, doesn't it?
It really does. And we're just getting started. There's a lot more to unpack here, but we'll have to save that for part 2 of our deep dive. So stay tuned because we're going to explore the implications of this discovery for the search for life beyond Earth and what it means for our understanding of the early solar system.
Yeah, it really makes you wonder, if something like this could potentially get life going here on Earth, could something similar have happened on other planets? It kind of adds a whole other angle to the search for extraterrestrial life. Maybe we should be looking for signs of ancient impacts on those planets, too. That's a really great point. I hadn't thought about it like that before. It definitely broadens the search, right? Instead of just looking for planets that are, in that habitable zone around their stars, maybe we should also look for evidence of past impacts that might have created these life-friendly environments, even if the planet itself isn't quite right today.
Exactly. It's like giving astrobiologists a whole new tool to work with.
Hmm.
And, this research ties in nicely with some of the work being done on extremophiles, those organisms that can survive in, well, some of the harshest environments on Earth, like deep-sea vents or super salty lakes.
Oh, right. I've read about those. They're incredible. They can thrive in conditions that would kill most other life forms. So are you saying that studying extremophiles could give us clues about what kind of life might have emerged in those impact-created environments billions of years ago?
Exactly. If life could pop up and thrive in those crazy conditions on early Earth, it makes sense that similar life forms could exist on other planets that have experienced similar events. Okay, so we've got this one impact that maybe sparked life, helped to shape our planet's crust, and might even hold clues for finding life elsewhere in the universe. This is pretty wild stuff. But I gotta admit, when I first read about this crater, I was a little skeptical. I mean, the article mentions it could be over 100 kilometers wide. If it's that old, wouldn't we have noticed it before now?
I know. It's hard to wrap your head around, isn't it? But you have to consider just how much our planet has changed over time. I mean, billions of years of erosion, sedimentation, tectonic movements, all that stuff has reshaped the Earth's surface. That crater, even if it was massive, has likely been worn down and partially buried over time.
So we're not talking about some giant, obvious hole in the ground.
Not anymore, no. That's why researchers have to rely on geological evidence like those shatter cones to confirm the impact. It's a bit like detective work, piecing together these clues from the distant past to uncover this hidden event.
Speaking of detective work, the article mentions a comment from someone named John Bayer who questioned the artist's depiction of the crater. He argued that a crater that size would be hard to miss.
Yeah, and that's a perfect example of critical thinking. It's good to question what you see, even in scientific representations. While the crater may have been enormous right after the impact, we have to remember that geological processes work on very long timescales. What might have been this dramatic scar on the landscape billions of years ago could have gradually been smoothed over and obscured over time.
So the artist's depiction might be a bit of an exaggeration then.
It's possible. It's important to remember that these depictions are often interpretations based on the available data, and as we learn more, they can change.
So what's next? We've found this incredible crater, but I'm guessing the research doesn't just stop there.
Oh, absolutely not. This is just the beginning. Now that scientists know what to look for, they can start searching for other ancient impact craters, potentially uncovering even more about Earth's early history.
So it's like we've just scratched the surface, and there's a whole lot more to discover.
Exactly. It's a good reminder that we still have so much to learn about our planet. Who knows what amazing discoveries are still waiting out there.
It's exciting to think about.
Yeah.
All this talk about Earth's early history and extremophiles has got me thinking, what was Earth's atmosphere like back then? Could anything even survive on the surface?
Yeah, that's a good question. I mean, when we think about those early days, it seems like it must have been pretty hostile, right? Volcanoes erupting all over the place, meteorites crashing down. Not exactly welcoming, right?
Right. It was a pretty wild time to be alive, that's for sure. And yeah, the atmosphere was a lot different back then. It probably had a lot more methane and carbon dioxide and very little oxygen. Definitely not the kind of air we could breathe.
So how could anything survive on the surface? I mean, besides those extremophiles we talked about huddled around those hot water pools. Well, that's the thing. Early life would have been very different from what we see today. We're talking about simple, single-celled organisms, maybe similar to bacteria. These organisms could have thrived in those oxygen-poor conditions, and some might have even been able to use those gases like methane for energy.
Okay, so it's like a completely different kind of ecosystem than what we're used to. That's pretty amazing to think about how life adapted to such extreme conditions.
It really is. And this discovery of the oldest impact crater gives us even more clues about what those early conditions might have been like and how life managed to, get a foothold.
So just to recap, we've learned about this incredibly old meteorite crater, what it tells us about the early solar system, how it might have even kickstarted plate tectonics and potentially even paved the way for life on Earth. It's pretty mind-blowing when you think about it.
It really is. It's amazing what we can learn from these discoveries. It really shows the power of scientific inquiry, constantly uncovering new pieces of the puzzle, revising what we thought we knew about the past, and opening up all these new avenues for exploration.
Yeah, it really makes you wonder what else is out there. What other secrets are buried beneath the surface just waiting to be discovered?
That's what I love about science. Every new discovery has the potential to completely change our understanding of the universe and, our place in it.
Well, I think it's safe to say that this deep dive has definitely given me a whole new perspective on Earth's history. It's definitely given me a lot to think about. How about you? What stands out to you the most from what we've talked about today?
For me, I think it's that connection between these catastrophic events and the potential for life. It's kind of a reminder that destruction and creation are often intertwined, and sometimes those really unexpected events can lead to the most remarkable outcomes.
Yeah, it's a good reminder that even when things seem chaotic and uncertain, there's always the possibility for something new and amazing to emerge.
And who knows what incredible discoveries are waiting for us in the future, right? Maybe one day we'll find evidence of an even older impact, pushing back the timeline even further, or maybe we'll find signs of ancient life on another planet, proving that we're not alone in the universe.
The possibilities really are endless. So to all of you listening, if this deep dive into Earth's ancient past has sparked your curiosity, I encourage you to keep exploring, dig deeper into the research, ask questions, and keep an open mind. You never know what incredible discoveries you might uncover. Until next time, keep looking up and keep diving deep.